My name is Mike Toole, and I have the honor of serving as the Dean of the College of Engineering here at University of Toledo. As we close out National Engineers Week, it's my pleasure to welcome you all to the ninth seminar in the Technology Takes the Wheel series. This series began in February 2018 with an idea to educate both the engineering profession and the public on the subject of autonomous vehicles with our partner, AAA of Northwest Ohio. Since that time we began, we have covered the safety of security of this data and information-rich autonomous vehicle ecosystem, public transportation and autonomous vehicles, the infrastructure and government regulations that will be involved in this new technology, the way autonomous vehicles will change the world of accessibility for the elderly and disabled segments of our population, how autonomous vehicle technology is changing automobile manufacturing and workforce development and preparing your workforce for the future. This series of autonomous vehicles and smart infrastructure has helped put Northwest Ohio on the map for smart infrastructure. Today, we're going to address the important topic of keeping pedestrians safe in an autonomous vehicle world by discussing some of the cutting-edge strategies in machine learning and algorithm development that can safeguard pedestrians in our increasingly distracted driving environment. We join with our partners in this series, AAA of Northwest Ohio, in celebrating the achievements of fellow engineers and scientists in creating the technologies that I'm confident will significantly reduce traffic deaths around the globe and provide mobility to millions who would not otherwise have it. Thank you for joining us here today. And now it's my pleasure to introduce you to our MC for today's event, Miss Lisa Guyton from 13 ABC News. We've been very fortunate to have Miss Guyton as our MC for the entire speaker series. Lisa has been a television anchor and reporter for nearly 30 years. She spent the last 15 years working at 13 ABC. Lisa grew up in Perrysburg and graduated from Maumee Bay Country Day School. She has a degree in communications from Stevens College in Missouri and is grateful to be doing what she loves in her hometown. She's been covering the auto beat for more than a decade. Of course, a lot of the recent coverage is focused on self-driving vehicles. Lisa also reports on many animal, business, and human interest stories for the station. She describes herself as fiercely loyal to our city, and Lisa is proud to be involved with events like Technology Takes the Wheel. In her free time, Lisa volunteers for a number of charitable organizations in her community. She also spends much of her spare time with real horsepower. She's an avid equestrian who began riding horses at the age of 4. Please join me in welcoming Lisa.
Thank you so much, and good morning, everyone. It is my pleasure to be serving once again as the moderator of today's discussion, an important discussion. The University of Toledo College of Engineering and AAA of Northwest Ohio are proud to host today's virtual event on the topic of pedestrian safety in relation to autonomous vehicles. Now, we have some excellent speakers on an exciting topic that will have an immeasurable impact on all of us. Now, as guests are joining us this morning, I want to share a few housekeeping items about our virtual event today. Attendee names are not visible to other attendees. They are only visible to hosts and presenters. Therefore, you will only see your name in the attendee list. For today's Q&A segments, we request that you submit questions using the chat box, which will be monitored throughout the session. And now to access the chat feature, click on the chat icon at the bottom of your screen. The chat panel will appear in the right button column. Please be sure to specify which panelist your question is addressed to. Additionally, if you would like to change the view on your screen, you can click in the upper right corner of your screen to expand or reduce. Now, there will be an opportunity for questions during the panel discussion after intermission. Please submit your questions for our panel discussion once again in that chat box that I just explained. Be sure to include which panelist, once again, to whom you are directing the question, if it is for one person in particular. Now, the first speaker in our lineup today is Mr. James Jennis. James is the Associate Director of the Center for Transportation, Technology, and Safety Research for WESTAT. James has more than 25 years professional experience conducting projects in transportation, visual perception, and communications. He has directed numerous research projects for US DOT clients, safety organizations, and automobile manufacturers on topics like driver distraction, automated and connected vehicles, feedback systems for novice drivers, and voice control systems. His expertise in quantitative and qualitative research techniques includes laboratory experiments, fieldwork, on-road studies, statistical studies, focus groups, contextual interviews, and usability testing. Dr. Jenis has a PhD in psychology from the University of Michigan. Please join me in welcoming him.
Thank you, Lisa, and thank you everyone for inviting me to the session today. I'm really excited about the panel discussion that's going to be coming up a little bit later. So the topic that I wanted to talk to you today about is a way for vehicles to communicate with pedestrians and with other shared road users. And so the title is External Human-Machine Interfaces for Autonomous Vehicles and Design Challenges. And so since this is kind of an engineering-oriented thing, I want to talk about some of the design challenges to think about when we're talking about external human-machine interfaces. But first, I have a few definitions. So I know that the series has made a lot of use of the term autonomous vehicle, and we see that a lot in the press and stuff. And I don't particularly like it for my presentation today because I think it doesn't have like a crisp definition to me, and it also kind of implies that the vehicle is doing an awful lot of has an awful lot of intelligence that some vehicles with lower levels of automation don't necessarily have. So we're going to stick to the SAE, Society of Automotive Engineers, definitions of automation. And so I'll primarily be talking about vehicles that are automated driving systems with levels 3, 4, and 5 automation. So the key thing is that these vehicles, the responsibility for primary vehicle control rests with the vehicle rather than with the driver. And the lower levels of automation up to 2, the primary responsible for vehicle control is with the driver. And so there's that distinction between level 2 and level 3, which is important. And then the other thing, a definition of external human-machine interface. I'm not sure everyone has heard that term before, and so I wanted to define that. So I'm defining it very broadly to include all the aspects of the external vehicle. So we're talking about the signaling systems that are on the vehicle primarily, but also the vehicle's behavior, actually, which is going to be under algorithmic control. And that can signal something about the vehicle's intended actions. And then, so we're talking about all the kind of external things that you could see and hear from the vehicle as part of the external interface to the vehicle. And then when I talk about the users of the vehicle, today we're talking about pedestrians primarily, right? So what I mean by that is the people who interact with vehicles, ADS vehicles, who are not necessarily inside the vehicle themselves, but they're around the vehicle. And for them, it's very important that the external human-machine interface is informative about the actions and intentions of the vehicle. So that gets rid of some of the definitions for today, and now I want to jump into some more fun things. So here's a picture for you, Lisa, of a horse. The reason I put this up is so we're talking about an external interface for a vehicle. The question is, well, what really needs to be designed, if anything? And this is an ad that was done by Porsche many years ago, and I think the point of it was to kind of show, the engine doesn't necessarily need to be in the front; the engine could be in the back, and so that was kind of maybe a radical idea, and there's some good reasons for that. But if we're talking about creating external human-machine interfaces, what are the needs for that? Why might we need to do that? Or at the end of my talk, I might say maybe we don't need to do it, but for now, let's talk about all the reasons why we might want to do it. Okay, so this is, I was in the airport in San Francisco, and I saw this sign just as I was coming out of the baggage handling area or the baggage claim area, out the doors. This is like typical of every airport, right? You come out the doors with your baggage, and then there's this big sign up that said, make eye contact with the driver before crossing the little street there. And this is really the crux of the issue here for my talk today, is that they're suggesting that in order to cross in front of a vehicle, you really should make eye contact with the driver. And human drivers provide a lot of cues to pedestrians. So they provide explicit and implicit cues that communicate their awareness and intentions. So, and we know from some of the research that we've done recently how pedestrians and other shared road users make use of those cues to understand, you know, is it really safe to cross, for example, or a lot of other things about the vehicle to predict the movements of the vehicle. Now, for ADS vehicles, there'd be the situation where many of those familiar and useful cues will be absent, or even worse, they might be unreliable or misleading. So just because there's a vehicle occupant sitting in what we think of as the driver's seat doesn't necessarily mean that that person is in control of the vehicle anymore. So they may be looking at the pedestrian just because, you know, that's an interesting looking person, or whatever. Like they may not be communicating in the same way that a driver who's in control of the vehicle would be communicating. And so there's a lot of opportunity for pedestrians to misunderstand the situation there if they're relying strictly on looking at a person inside a car. There are other ways that that vehicles communicate, or that drivers actually are communicating now with external users. So for example, there are signaling systems on the car now, like turn signal, brake lamps, backup lamps, horn, hazard lights. All of these things are used by drivers to explicitly communicate their intentions, or to communicate kind of the state of the vehicle. And then there are what I call driver person cues. So those are things like is being shown in this diagram here, where you know, pedestrians can learn things about what's going to happen from looking at the driver of the vehicle, the driver's head pose. There could be gestures that the driver could, for example, wave the pedestrian on to say, okay, it's fine to cross. Sometimes, if you're in close proximity, you can see the driver's facial expressions, or body posture, things like that. All those kind of driver person cues. And then there's also what I call vehicle dynamic cues, and these are also important, and we know that they're used by from our research, we know they're being used by pedestrians and bicyclists and other road users. So those would be things like just subtle movements of the vehicle. So for example, the position of the vehicle within its lane. You can predict, like if you see a vehicle ahead of you that kind of moves over to the right in its lane, you might predict, okay, I could see that vehicle is getting ready to make a right turn, for example. Or for pedestrians, speed changes are very important. If there's a vehicle approaching and you see that the vehicle kind of suddenly slows down, you may have some indication that the driver has seen you, or that the vehicle is going to yield to you. So we'll go to the next slide here. So so basically, we want to think about what needs to be replaced if there is no human driver, and what are some of the situations that would be important for thinking about this problem. And so some of those situations in traffic would be things like negotiating, coordination between vehicles. So like the turn taking that occurs when you're merging onto a highway, or if you come to an intersection and it's a kind of a complex intersection. Sometimes vehicles can get stopped like out in the middle of the intersection, or there can be other complex interactions that are not strictly just simply following rules of the road, but there needs to be some kind of communication in a way between drivers, or in this case between vehicles, to allow for that kind of negotiation to occur about who's going to go first, you know. And then there may be Another thing that we may be missing is social communication, I'll call it, but there's a lot of social communication that occurs where, you know, let's say communication between pedestrians and drivers where there's thank you waves and other kind of gestures that happen, or just kind of merely glancing and smiling, that kind of thing. That sort of stuff won't be supported if the occupants of the vehicle are kind of clueless to what's going on around them, which may be the case in higher levels of automation. So this woman here in the picture is just kind of reading a magazine or something. And then finally, warning situations. So you know, if there's a kind of a opportunity, maybe there's an imminent collision risk or something like that, you know, you may blow the horn or to warn people, or to make sure that the pedestrian sees you as a driver. You might give a little honk to make sure that they see you coming. Those kind of things would have to be replaced to ensure safety. We'll go on to the next slide. And then there are also things to think about for ADS vehicles where, you know, there may not even be any human occupant inside the vehicle at all. So this is a truck that doesn't really have any human occupant. Some of the things that you may want to communicate from an external HMI in this case would be the fact that it may be very important to clearly communicate that there is no human in control of the vehicle. For example, you may want to communicate any kind of error states in the automation. You know, if the automation is in some uncertain, if the automation is kind of feeling uncertain about the situation, you may want to communicate that. Other kind of needs for communication include our application-specific types of communication. So, for example, if a vehicle is being used as like a taxi or maybe a delivery service, there may be a need to communicate with pedestrians or customers about things like, you know, is this the correct vehicle that you have summoned, for example? Is this a vehicle that's expecting to pick you up? You know, or is it safe now for me to enter the vehicle? I might need to know that from the vehicle communicating with me. And then finally, another thing that could happen is there might be a need for the vehicle to communicate something about its state if it's under threat. So, for example, you know, if the vehicle is being misused, there may be some alarm system, or maybe somebody's trying to break into the vehicle, something like that. There may be some need for kind of the vehicle to have some kind of self-defensive communication system. Okay, and then so that as we're moving into sort of how to do this, I like this picture quite a lot. So we already know how to make wheels that work pretty well. So maybe there's not a need to do something completely radical just for the sake of doing something completely radical. And there are existing guidelines, principles, and standards for vehicle design, including SAE standards for human-machine interfaces. And some of those things that are some of the principles behind guidelines and guidance for human-machine interfaces inside the vehicle, some of the principles could be applied to external HMIs as well. And then we also need to worry about federal regulations on vehicles. So for example, there's the Federal Motor Vehicle Safety Standards that controls the use of, you know, lighting systems on vehicles and things like that. Those may need to be modified in the future if to accommodate new external HMIs, for example. So then I want to run through quickly some design challenges that I see for these external human-machine interfaces. The first of which is this kind of complex need for, we want to achieve usability. That's sort of one design goal, but we also want to achieve kind of public acceptance of automated vehicles as well. And sort of going along with that, we want to be able to kind of calibrate the public's or the pedestrians' level of trust appropriately. And so the question is how to do that through design. And we can rely, so there's these two big arrows on the slide. One is existing knowledge and expectations. So people already know a lot about vehicles and they've experienced vehicles as they exist today. And so we can build upon that. One thing to do is to build upon the signaling systems that are already on vehicles because people kind of understand those very well. And there could be some incremental changes. So for example, for a turn signal, maybe if we wanted to transmit even more information about the fact that the vehicle was preparing to turn, we could say increase the flash rate of the turn signal as the vehicle gets closer to the point where it's going to make the turn, for example. It's just one example. So there are ways to kind of leverage existing signaling systems in slightly new ways, just kind of pushing them forward a little bit. But then we also can consider that humans and pedestrians in particular have tremendous capacity for learning new things, and so it's not out of the question for us to, if we need to have novel signaling systems on vehicles, it's certainly a possibility to introduce novel systems on vehicles as well. We just have to there have to be some education of the public and so forth to make those effective. We've seen examples of new signaling systems introduced on vehicles. So for example, the high center mounted brake light was introduced many years ago. And I think it was introduced as a safety measure to try to reduce rear end crashes. And what's interesting about that is that it actually was quite effective at reducing crashes. Some of the studies say about 15% reduction in crashes. However, over time, that benefit was reduced to something like 4%. And so as people get used to things, there's some benefit of novelty, and then as they get used to things, they may adjust. For example, they may adjust their following distance, reducing their following distance because they have this extra safety layer of the third brake light. So that's kind of a thing we need to worry about with external HMIs, new external HMIs as well. Another design challenge is to communicate with the appropriate users, and by users I mean pedestrians in this slide. Got a lot of happy pedestrians here. Here it's difficult. It'd be difficult for the vehicle to isolate messages to specific road users. So for example, if you were the vehicle designer and you wanted to be able to send a message to a particular pedestrian to say, I'm going to yield to you. It's not clear that would be a very easy thing to do because there's all these other people around. There's a lot of, in a city environment, there's a lot of noise and other kind of things. So that's kind of a challenge to sort of communicate with specific people. It may be better. An alternative is to kind of shape the messages they're communicating so they're more generally about the vehicle's intention. So just saying, if the vehicle were just to transmit a message of "I'm yielding now" without any kind of directionality or kind of picking out particular pedestrians, that might be a better idea. We also need to think about principles of universal design and the fact that the external HMI needs to be usable by a variety of other road users, including different pedestrians. So, we have younger pedestrians, older pedestrians, pedestrians who don't have vision, all sorts of things. And so the types of HMI that external HMI that we develop we need to think about all the different types of users that may come in contact with that vehicle. And that's a wider I'll just point out that's a wider range of users than the users who sit behind the wheel of a car. So that's it's a much more restricted set of people who actually drive than it is people who actually are pedestrians. So that's a big design challenge. We also might want to consider what do we do about non-human, like animals running in front of the vehicle, things like that. Humans might honk their horn or things like that, and some of that might need to be done with automated vehicles as well. Another design challenge is to communicate with the appropriate timing, and this is sort of a tricky thing. The last slide sort of had to do with kind of communicating to the right spatial area around the vehicle is a challenge. So this one has to do with communicating at the right time. And so, for example, if you had some signal that said, I'm preparing to move forward, or I'm preparing to back up, when do you start doing that? How far in advance would you do that before you actually started to move? If you're coming to a point where you're going to make a turn, how far in advance do you initiate a turn signal? That sort of thing. Those kind of timing issues are a challenge. Then another challenge is to consider the entire traffic context. And if you look at the slide on the left there, there's a lot of vehicles on that road, and you can imagine that if every vehicle had its own kind of design for its external HMI, it would be very difficult for people to understand what was going on. And so there is, just like there is a standardization need for the kind of signaling systems we have now, there will be a standardization need for new external HMIs, so that there's some principles or some uniformity among vehicles, so that pedestrians can, when they see a new vehicle coming and it has a signal, they can understand the signal immediately. It's not like and it's not like every vehicle has some kind of different system on it. And then the other thing I wanted to point out is that the context might matter. So for example, here's a rural area on the right, and in rural areas, there might not be edge lines on the roads. There might be a lot of maybe there's some local customs that need to be considered. So for example, maybe people in rural areas are very friendly, and they're used to like having the passing vehicles, having the driver wave at them when they go by. That kind of thing maybe could be considered in external HMI as well. And then finally, the needs for different kinds of weather conditions and that sort of situation. If you had a vehicle that had no occupants at all, for example, there could be a need for that vehicle to communicate that it's a little uncertain. It's a little uncertain because a couple of its sensors are blocked by snow, so it's okay to continue on to its home base, but it's traveling slow because it's a little uncertain about the position of the road, for example. Okay, and then here's another thing that happens sometimes with technology design, is that we kind of overdo it, and so just because it seems really cool to do something, sometimes it's too much, and so this is a concern. In that previous slide, I showed you all those vehicles on a crowded highway, and sometimes if you have too many signaling systems on a vehicle, that could lead to pedestrians not really seeing the important one, or if you have too much signal, the signals itself become noise, and you're not able to detect the important signal within that noise. So I think it's something to think about is the most minimal design that is effective might be something to think about. And this is sort of my last point. And one thing that I want to leave you with to think about is a little thought experiment. what would happen if we just eliminated brake lights and turn signals? Okay, you think, well, we might have tons of more crashes, right? But actually people would adapt to that, right? And they would actually be much more careful drivers probably. And vehicle design would be simpler and everything. I mean, it's a controversial point, but my point is that it may be for external HMI, maybe we don't need to have any additional external HMI for automated vehicles at all. Maybe just the current signaling systems could be used in sufficient ways that that's all we need. You know, if we have those automated vehicles behaving so that the vehicle dynamic signals are similar to human drivers, and the signaling turn signals and brake lights and all that kind of stuff is similar to what we have now, maybe that's all we need. So I'll just leave you with that, and we'll move on to the next speaker. But thank you very much for your time, and I look forward to the discussion afterwards.
Thank you so much, James. And of course, remember to submit your questions in the chat section. And James, you win an award for, I think, one of the best slides of that old-time trotter in there. So thank you very much for.
I thought you would like that.
I did. I loved it. It's a great old picture. Our second speaker today is Mr. Assam El-Zukri. Assam is the founder and CEO of Intivo. It's a skilled software engineer, experienced in AI and machine learning. He spent several years as an automotive software engineer and has acquired substantial experience in the autonomous vehicle industry. Now, his vision is to use AI to solve complex problems in automotive and other industries in order to bring pedestrian prediction technologies into vehicles, thus addressing one of the greatest challenges in road safety. Intivo is a software company that leverages artificial intelligence and machine learning to understand and predict pedestrian behavior in the context of autonomous cars and fleet vehicles. Please join me in welcoming Assam.
Thank you very much, Lisa. And I would like to thank the University of Toledo and AAA for inviting us to this webinar. And it's a great kind of environment to kind of discuss about pedestrian safety. And I just want to thank James as well for talking about, you know, kind of pedestrians, how they can communicate with drivers, as well as how drivers actually communicate with pedestrians. And that's what brings us back to what we're doing and the reason why we started Info. Just in a high level, Info is a startup located in Ann Arbor, Michigan that specifically just focus on pedestrian safety. We definitely focus on trying to understand how these pedestrians are interacting with driver, but also we want to understand how actually drivers are also interacting with pedestrians, especially in urban environment, because that's where many accidents actually occur. Just in high level, our company is building a commercialized vehicle. I mean, commercialized software that will be deployed into a big commercial vehicle in the near future. So our company is working with a top tier 1 and OEM in the market to take our technology and deploy it into today's vehicles. So we do have an office located in Ann Arbor, but also we have another office located in Detroit here. And we're working to deploy our technology in the region of Ohio and other different states as well. So we started our company back in 2018, again, specifically focusing on pedestrian safety. That's exactly what we do. That's what we've been doing since the beginning, and we continue to do so. We actually have a good relationship with big kind of customers like EI, Hyundai Mobis, Volvo, Denso, EDL, who's actually making an impact in the automotive, and we're leveraging that type of communication. So I guess I want to talk about what I'm going to be presenting today. What is the topic that I'm going to be talking about? So again, obviously, I'm going to be just discussing specifically on pedestrian safety, and why pedestrian safety is really important today to talk about. In addition to that, I would like to talk about how driverless vehicle today or autonomous vehicle today see the world around them, and what are those potential technologies that can make these autonomous vehicle more an environment where they can operate. In addition to that, I would like to talk about, I guess, a quick into how scooters today are operating in urban environment and how they can cause also accident and injuries to other road users. In addition to that, I just want to highlight and talk about specifically about the technology that what we're doing, which is why human behavior predictions is so important to the market. And what is Info today is doing differently that is trying to make an impact on today systems and vehicles. And I would like to show a quick kind of a software demo that demonstrates our technology in today's market. Just to jump in quickly into talking about first why pedestrian safety is important. Just to highlight, pedestrian death has been on the rise in the United States for over a decade. And these numbers always continue to rise day by day. And not to mention every 1.5 hours in traffic, there's always an accident and pedestrian is killed. Even talking about the pandemic in 2020, there was a research that gets published that showed that even with less vehicles on the road today, there is actually pedestrian that continue to rise, even with less vehicles on the road. And that's where we want to talk about and focus on this specific problem. And also to mention that AAA in 2019 actually published and showed the research the vehicles today that actually in the market that has very limitation of technology that is trying to prevent accident. So they actually warn pedestrian detection system that is actually in vehicle today doesn't even work when needed the most. As you can see, an accident can happen when just few seconds. And the reason why is because today we do have a distracted driver, but also we do have a distracted pedestrians. And that's kind of a deadly combination from both that can cause these issues. And to just moving on, obviously we all know there's a lot of scooters on the road that is actually happening around in different cities. And there's also just a research that's published in Washington, D.C. that refer to nearly 3 in 5 scooters were injured while riding these on the sidewalk. What it means is like today we have kind of scooters that's riding on the sidewalk, some of them actually riding in the main road where vehicles actually moving, and there's a potential of collision, either with pedestrians or with vehicle. And what some companies today is trying to do today is how they can install some camera vision or a system that can be mounted into these scooters. And the purpose for that is once the scooters can detect there is a pedestrian on their path, the scooters will start maybe reducing their speed or sending an alert to the rider or to the pedestrians to let them know that there's a scooters coming. So this kind of probably some of the technologies that trying to prevent those accidents. Obviously, probably these systems are not very efficient today, especially with the current system when it's come to machine learning and computer vision, because you need to have a very powerful system that's running these algorithms in real time. But we're actually moving in that right directions where we can eliminate and prevent accident. Again, there's a lot of kind of corporate and companies trying to kind of take a role in this to help mitigate those type of risks. And just in this slide, I just want to highlight the, what are those tips that we always need to keep in mind when we actually crossing the road, because all of us are pedestrians and we need to keep our as a safety. One of those things is obviously we have to follow all the rule roads and looking into signals, which James mentioned, like some of the vehicle signals, road signals. We have to keep an eyes on those and make sure we eye contact with the driver before crossing on the road. And also always we have to keep in mind that we always need to walk on the sidewalk whenever it's possible, just to eliminate and reduce that type of risk. And also, if there is no sidewalk, if you're walking on any road, always try to face traffic and try to have any eye contact with the driver. Is really important. The moment you start having eye contact with the driver, it's reduced the risk of collision in that case. And not to mention, which is obviously the most sad, is many people are today distracted by electronic devices, either the driver or the pedestrians. So we always need to keep our eyes on the road and try to reduce devices less when we walk on the road, because it's really important. And that's one of the main cause of today's accident, is because people are really distracted and so much better than ever. So we just need to keep, kind of preventing using these devices when walking on the road. I just want to talk about this slide, which is kind of bring an image of our kind of cameras that is actually installed in vehicles. Just to give, kind of to bring us back all the way to the beginning, why we started Info and what we're doing here. So as you can see, this is just a screenshot of our kind of camera that is actually mounted in the vehicle. The moment you look at this image, obviously it's quite easy for us to understand what's going on in this image. You can see there is obviously two pedestrians here. One is a bicycle, and there's a lady here who actually having an eye contact with the driver, but also we can see their directions. Actually, they're moving toward the crosswalk. They actually has the intent to cross the road. And also we can see there's another person here who actually was crossing, but now he's actually moving to the sidewalk. Obviously, there's another people who are actually walking in the campus. This is actually at the University of Michigan. What I'm trying to point here is something that we actually look for is trying to understand exactly what's happening in this case scenario, and why we need to understand this type of information. So you can see that in this slide, we kind of highlight in red. These are the main kind of pedestrians that we have to keep in eye contact with, and make sure that they have a higher risk in this case while crossing the road. So the good news is, in today's market, there is obviously many kind of autonomous companies who are actually trying to bring an artificial intelligent autonomous that will eventually in the near future will have that capability to operate by itself in urban environment and any type of roads. But the question today, are we ready for this type of technologies? Are we ready? Are these vehicles are ready? The question is not really, because there is a lot of work that needs to be done. And this is just highlight of what's in the market today. So this is how current autonomous vehicle is actually seeing the road. As you can see, these vehicles are using different type of sensors to understand the environment. For example, they're using LiDAR. This LiDAR is giving the vehicle capability of understanding the roadmap environment of the surrounding. In addition to that, these other sensors also have the capability of understanding the type of object. This object could be a pedestrian, or it could be a bicycle or a motorcycle, but also it could be another type of vehicles that is actually moving in the space. But also we're trying to analyze understanding where the directions of these vehicles are moving within the environment. In the left image here, we're actually showing a computer vision system that has a capability of recognizing traffic light. In addition to that, we're trying to analyze pedestrian, bicycle, and vehicles as well. And that's kind of a combination of system that we're putting together to be able to understand the surrounding of the vehicle. And just to clarify here, some of the questions that we need to answer, which has not been answered yet, is by looking at these pedestrians who are here actually probably moving on the sidewalk or actually has the intent to cross the road. The question is, do we know if these pedestrians are going to cross the road? So that's a question that we're trying to answer. Just going back to the same slide that I was talking previously, is the same question. Are they going to cross? So that's a question. And how do we know these pedestrians are going to cross the road? It's the exact same way as human. When you drive the vehicle, you immediately know if that person is actually trying to cross the road, or is he just waiting on the sidewalk. So, and these are the exact same question that we at Info are trying to answer, is how do you determine when a person is going to cross the road? Obviously, some of the clues that you want to look into is the eye contact. Are they aware of the surrounding? Do they pay attention to the driver? Where are these pedestrians are going? Are they going to cross the road or not? So for example, here we can look at the some of the information is awareness, probably standing. Is there any traffic light or is there any crosswalk that give us a clue that this is a designated area for pedestrians to cross? And what is the type of body movement? So we can calculate the speed of the movement of the pedestrians where they're going. And as I mentioned, it's just trying to look into the crosswalk area as well. So these are some of the clues that we need to understand and to be able to predict if these pedestrians are going to cross the road. So this is bringing us back to what we're doing at Info. I guess I want to talk about and highlight what we're doing at Info. So Info is a startup, as I mentioned, in Ann Arbor that we actually leveraging computer vision. So we're using a signal camera, or we can use like 3 surrounding 60 cameras that could be mounted in the vehicle. And we rely heavily 100% on guest cameras that could be mounted on the vehicles. It's the same way as human driving the vehicles. We have our eyes, we can see the road, we can predict and analyze, and that's exactly what we're trying to do here. So we're not using any other sensors like radar or anything like that. So we're just specifically focusing on just using cameras because we believe cameras have that good capability of understanding of the surrounding. So in this case, for example, which is kind of demonstrate of our kind of previous software that we built back in 2019, and today we have a much better software. So previously what we're doing is we were just using some of the body pose, which kind of understanding the body movement. In this case, for example, we can look into the type of the person. Is it a child? Is it an adult? And so on. So we're trying to analyze that type of person first. And then moving on to the head pose or head position, we're trying to analyze where is that person is looking. Is that person is paying attention to the vehicle? Is that person looking away from the vehicle? In addition to that, as I mentioned, we look at the eye contact. We're trying to understand does these pedestrians have any eye contact with the driver? And also, which is the most important thing, is we're looking into any type of object those pedestrians are holding in their hand. In this case, as you can see, this lady is holding a cell phone. So we can kind of flag or kind of let the vehicle know that that person is holding a cell phone, and what is that person is doing with the cell phone? Is that person just looking at the cell phone? Is that person is talking in the phone, and so on? So that's what we're trying to figure out here. In addition to that, we're trying to look into the feet position, because every step the person's taking is very important. So we need to calculate those steps that person is taking before they cross the road. And also looking into the leg movement, so we can try to analyze how fast is that person is moving within the space around the vehicle. In addition to that, obviously we want to look into the arm movement. From kind of discussing is, does these pedestrians have any kind of waving gesture? Like are they waving at the driver? Do they tell to the driver to stop, or do they say thank you to the driver even if the driver is giving them the opportunity to cross the road? So this kind of the type of communication that we want to understand and try to kind of predict. In addition to the, obviously, weather condition is so critical, especially here in Michigan, obviously in Ohio, and different other states, because the moment, for example, if there's a lot of snow outside, it's hard for the vehicle to see the surrounding in a better, for example, lane, road. Sometimes it can be very difficult for the driver also to see the surrounding area. In addition to that, obviously, when the weather is so cold outside, many people wearing heavy clothes, which is make it a little bit more difficult and challenge for autonomous vehicle to understand the shape of the body, obviously. And we're actually collecting data that kind of teach our model to learn based on the information. And obviously, the one before the last one is which is the risk level. And probably you may not sure what it is. So this one, actually, we are actually assigning a risk level for each person. And the way we're kind of assigning the risk is based on the behavior that we're actually analyzing in the human body. For example, if a person has if the person is actually distracted and he's walking, crossing the road, and he's not paying attention to the vehicle, so we're actually assigning a high risk in this case. Person just walking on the sidewalk, and he's actually paying attention. He's not distracted. He's not in the area of interest of the vehicle. We're assigning a low risk. And this is kind of where, take me to the slide, which kind of explain in a much better way. Is for example, the first image here, you can see this lady is actually looking into at the driver. She's actually waving at the driver, and also we're calculating the distance, how far is that person from the vehicle. So in this case, we are understanding that that pedestrian is actually interacting with the driver. So that's a low risk because we know that person is not distracted. We know that person is actually paying attention to the driver, but also we know that person is not actually in the area of interest of the vehicle, but he's actually has intent to cross the road. So we're actually assigning a low risk. Here, a second image where I kind of describe a bicycle. He's actually in the middle of the road. He's not paying attention to the driver. Obviously, he's obviously not holding a cell phone, but he's just moving in high speed around the vehicle. So we're kind of clarify this one as an awareness level. We're highlighting as a medium risk for that potential bicycle. The last image here demonstrates is the person is very close to the vehicle. He's actually holding a cell phone. He's not paying attention to the vehicle, so he's a very distracted pedestrian. And then we highlight a high risk. So these are kind of the type of information that we're actually looking for in order to determine when is risky for the vehicle to drive in any type of environment, and what does that mean? What does that risk means for the vehicle? So our company is actually collecting all that data in real time, and then sharing all the output with the autonomous and automotive suppliers to send a type of signal, letting them know that there's a high risk of a person is crossing the road who is distracted. And based on the information, the autonomous companies or an OEM can use that signal to either decrease the speed of the vehicle or sending an alert to the driver. Obviously, in the near future, hopefully in the future, we will be able to control the vehicle. But in the near term, goal is for us as a company is just to send a signal to the driver, or to send a signal so the driver the vehicle have kind of a capability to reduce the speed in this case. And this is just talk about what's happening in the today market, in terms of the current state of the art for machine learning to kind of look into doing object detections and understanding pedestrians kind of intent. So in today's market, obviously there's companies out there, and this is kind of some of the paper that's published to show some of the current work in today using machine learning to analyze and understand how pedestrians interact with the vehicle. With the current system today in the market that is actually looking into using just object detections, which obviously you're mounting a bounding box around the pedestrians. And then from there, you start doing some tracking. You can track that person. And then you can have multi-models that is actually looking into different type of behavior. For example, a model looking at distractions, another model looking at any kind of intention. And all of this actually working within as the backbone for the system, which kind of clarify if that person's crossing or not crossing. But the way the current system is working within this kind of structure of the model is very heavy for the model to run faster in today's commercial vehicle system, but also the accuracy is much lower. So info approach is we're actually using a Hydra loop. So this is our model. It's the patent product that we're building. It's a system that would kind of using, it's a we call it multi-head. Each head will focus on specific use case scenario. For example, one head will focus on the kind of intent to cross. So we can clarify, is that person crossing or not crossing? Another head will focus on for example, the awareness. Is that person aware of the surrounding or not? Another model also focus on the distractions level. So actually we're combining all of those heads into one serial like units where we can combine all of those together. And then when we run the model, we're actually just run a signal shot that we're doing at once to do all the predictions at once. And this will give us a much faster speed and also can give us a better accuracy. Back in 2019, we used to use some kind of more heavy neural network model. We were getting around, I would say, probably 6 frames per second on an NVIDIA Xavier system that we're using. Today, we are able, by using the Hyperloop network, we're able to achieve around 20 to 25 frames per second that is running in real time in the vehicle. And we're talking about like a very low-end device that could be running in a vehicle, and this could happen in real time. So we're making a tremendous amount of progress that this system could be deployed into a commercialized vehicle in the near future. And this is just talk about how are we doing this, how are we collecting the data, and how are we processing that information. Just to start, normally what we do is we collect data on the road. That data could be collected by using some vehicles. We can mount cameras in vehicles, or we can use some public data that's available for us from our customer or some universities that can provide us that data. So we can log all that data into our system. Once we log the data, then we start doing labeling. So we have some kind of client or team members who are actually looking at videos and then kind of clarifying what's happening in each frame. Is that person crossing? Is that person not crossing? And so on. Once we do that labeling, once we label all that data, then we feed all those data into the machine learning model. The model that we're actually choosing, as I mentioned, is we have built our own internal model, which is called Hyperloop. It's a machine learning model that is kind of has the capability to kind of read all that data information and then train the model based on that data. So we're actually breaking down that data into validation, testing, and train the model. So we have like 3 folders that we're combining together in order to teach our model. Once our model is trained and ready to go, then we deploy that model into the vehicle, and then we test the model in the vehicle and see how it's performing. If there's some use case scenario that the model is not performing so well, then we use the exact same recycle again and again, so the model can learn and better. Similar to what Tesla is doing today in the market, where they have vehicles on the road, they're collecting data, and the model may not predict correctly at some use case scenario, then they can push that data back to the cloud and then pull that data and then retrain the model again. This is the exact same concept that we're doing here, is to help our machine learning model to understand the intent of pedestrian. And in this slide, this is just a demo of our software. And I just want to highlight, actually, the system that you see here, actually right now, we're actually deploying our system into a commercialized vehicle. As you can see from the left is we are using a depth estimation system that calculates the distance from the vehicle, so we can know how far is the object from the vehicle. And this is just using camera vision. Probably if you have a new vehicle today, you might see like sometimes when you try to back up your vehicle, if there is a snow, you will start to hear that beep noise. By using camera vision, we can eliminate all of that noise in this case. And from the right side here, you can see our system model is actually doing some predictions. So we can predict how risk is that person who's actually surrounding the vehicle. Is that person has the intent to cross? Especially, for example, if you're backing out your vehicle, we want to be able to predict that type of kind of behavior to eliminate if there's any accident. And this is just one of the use case scenario. When you have your car in the parking lot and you try to back out your vehicle, we want to predict that type of behavior. Again, we're actually taking this information and deploying into commercialized vehicle with one of our OEM customer, and eventually this will be deployed to 360 surrounding system. Thanks to my amazing team for helping me building this amazing technology together. We have some scientists from the University of Michigan and some expertise from background in the automotive with over 30 years of experience. Myself, I used to work at Denza, which is an automotive suppliers, where I had good experience working in the autonomous space. So just to leave you with this, it was great to be part of this event, and I just hope that I can connect with all of you guys. If you have any questions about what we do at Info and how we're making an impact, and if you guys have any kind of suggestion or any kind of potential pilot that you want to work with us, we'll be happy to work with you. Thank you.
Thank you so much, Hassan, for sharing the fascinating work of info. I always am amazed when I listen to so many of the discussions that are part of Technology Takes the Wheel, because I think back to when I started my career in television, which wasn't all that long ago, but it was more than 30 years ago, and we were on typewriters. So it is amazing to see what's happened.
Thanks so much, Lisa.
Thank you. Our third speaker today is Mr. Bastien Beauchamp. Important is a digital safety belt, a free mobile app. He is the CEO of the company. It protects pedestrians, bicyclists, and motorcyclists by sending people's position to connected vehicles, therefore helping prevent collisions. Important aims to save 1 million lives over the next decade. Important was nominated for World Elite 150 Startups in Singapore in 2020 and Top 30 Startups of Silicon Valley in 2019. Bastien has over 20 years of experience as CEO of tech companies in Montreal, New York, and San Francisco. His work has been recognized by 29 awards from 4 continents. Today, Bastien is working to improve public safety in smart cities at Important. He also sits on the Communications Committee of PAVE and the ASC Sensor ADAS Autonomous Committee of the Automotive Safety Council. He also participates as an industry expert on the AV Steering Committee of the National Judicial College. Please join me in welcoming Bastien.
Hello, everyone. Can you hear me?
Yes.
Yes, okay, perfect. Thank you so much for having me today. It's an important topic, and any opportunity to talk about pedestrian safety is wonderful. I would like to specifically thank the previous speaker, Assam from Intvo, to introduce us to this event to the university. So thank you, Assam, and thank you all for listening to this. I'll try to be fast because I believe we're a little bit behind the schedule right now. So important what we do, we specialize in safety of people. So accidents that happen out of the vehicle. How does it work to change the slides? Thank you. So I'll just mention to change the slides during the presentation. So pedestrian fatality is a real problem. When you look at road fatalities, it's top 3 fatality cause in the US for 1 to 35-year-old. Pedestrian fatalities makes no discrimination. So it concerns old people, young people, children. We see stats every day, and it's not really pleasant. We work hard to change the reality right now, and we believe we have the solution. All the technology in the market right now can save the 1.3 million people who die every year on the roads. Most of the people who die on the roads are out of the vehicles. So it concerns pedestrians, electric scooters, bicycles, motorcycles. That's the people we address our technology to. Next slide, please. So the problem is well known. Our solution is to use the smartphone of the population. So detect people from their smartphone GPS coordinates, apply AI to these coordinates to know where people go and predict the movement of the people, predict the movement of the car as well, and prevent any possible collision. So the goal is to have the car brake automatically when it detects a GPS position and in an unavoidable or avoidable impact. So that's what we do. It works for pedestrians, bicyclists, motorcyclists, electric scooters, wheelchairs. We care a lot about accessibility. We want to prevent life's fatalities for everyone. Next slides, please. So our first commercial product is coming out in 2 months. It's a mobile app for commercial fleets or for school buses or for mining trucks or for forklifts, any vehicle that is can endanger people around. It's just a mobile app that shows the people around in the car, and with the information we can of course inform the driver, but if as a safety feature we would like as well to control the brakes if a collision is predicted. Next slide, please. So why do we do this? Why do we need smartphones in the equation? Why do we need to track people? Well, if you look at the pedestrian fatality causes, the edge cases, so on a daily basis, we as a driver solve a lot of the problems of possible accidents. So we save lives on a daily basis, but there are edge cases, and they're serious because there's 1.3 million people who die every year. So it's a serious problem to address. So next slide, please. When you look at the pedestrian fatality causes, it's always the same 20 scenarios that repeat over and over again, according to a qualitative study by the French government of transport, the Ministry of Transport. So we regroup at important the 20 scenarios into 4 categories. First category of edge cases is drivers are responsible because they're driving too fast, they're not attentive, they drank alcohol, whatever the reason, the driver did a bad job and hit the pedestrian or the bicycle or the motorcyclist. That can be prevented by all the technologies we put on cars. All the sensors like LiDAR, radar, sonars, and cameras, we try to replace the driver. We try to create a better driver than an actual human. So that addresses 35% of the cases. There are cases like visual blockage. That happens a lot. So it's not the fault of the driver. It's not the fault of the pedestrian. It's just the situation. There was a parked car or a parked truck. A pedestrian was hidden from behind the truck, so sensors or drivers cannot see through vehicles. So the pedestrian just appears in front of the road, and then bam, there's nothing the driver can do. There's nothing a sensor can do. There's not enough time to react because of visual blockage. Another category is unpredicted pedestrian behavior. So it's all good. We track pedestrians and we have AI apply algorithms to predict where people go, but it's very hard to predict a change of 90-degree fast and the pedestrian starts to run in the streets. That's very hard to predict. It's an edge case, and it happens quite often that pedestrians have unpredicted behavior. Now, with our technology, we can address that by using all the sensors in the phone. We know when there's a change of behavior, and we can predict within 80 milliseconds the change of behavior. So that's one thing we address, as well as visual blockage. Cell phone tracking works anytime. Like if a pedestrian is hidden behind trucks or behind cars, we still detect the person with the smartphone. So that's an advantage of the solution. The last category I'd like to address is the external conditions. So like bad weather, bad visibility, darkness, that happens. It's part of the reality. So there's nothing a camera can do when a chunk of mud appears on the lens. The sensor will stop or will need external help to work back again. So these external conditions, like I'm from Montreal originally, so Quebec, there's a lot of snow, very, very hard weather conditions. Good luck to any AV company to be in Canada. We believe in autonomous car. We want to work for that, but there's a lot of issues or challenges to solve still. All right, next slide. So we call that the sisters of safety, and today with actual technology, we can solve the pedestrian fatality problems. We could solve the fatalities with actual technologies, and it's just a matter of agreeing as an industry how to do it. but we could save 1 million lives over the next decade just with our technology. So how we analyze this is we saw that 35% of the accidents were due to bad driving. That's about a third of the edge cases. So a third of the fatalities can be addressed by all the sensors on the vehicle. You can put all the technologies you want on a vehicle. You will not track a kid that runs for a bulb that goes through two parked cars and appears in the street, or will not solve the trolley problem. There's a need to implement to ask infrastructures and IoTs for more information. So right now we see a lot in the industry. Engineers have a culture of having all the technology on the vehicle, and it's great. But the promise of smart cities will need that we extend the technologies out of the vehicle. Like we should include infrastructures, we should include smartphones, IoTs, and all these technologies that can help to save lives. So we know, another stats we know is that 1/4 accidents happen at the intersection. That means that 3 out of 4 fatalities happen in jaywalking when people are between intersections and there's no infrastructures there. So we can put all the technologies we want on infrastructures. We cannot solve the jaywalking problem if we put all the technology only at cross intersections. So that's why if you look at the remaining 2/3 that are not addressed by the sensors on the vehicle, out of these 2/3 left, 1/4 can be solved by the infrastructure-based sensors. So that makes 1/6 of the whole system. And the remaining half of the edge cases that are not solved by the sensors on the vehicle and the sensors on infrastructures, we just have smartphones to protect us in the middle of the street. So that can save half of the edge cases of the fatalities. Next slide, please. So there's 2 takeaways I'd like today is first the tech stack. So the technology stack, each technology that we use is not perfect. Like cameras don't work in all conditions. It works in most conditions, but there are edge cases. So we stack other technologies. So there are radars that don't work in perfectly in all conditions, but they work in most conditions. So when you put radars and cameras, you have a greater sense of reliability. It's called robustness. So when you add LiDAR, sonars, and our system with important and the infrastructures input, like from info as well on the car and on infrastructures, that can really help to bring more safety. Another thing is the trolley problem, the famous trolley problem, where an autonomous car or any car is about to hit people, the car can change direction and would have to hit other people. So the trolley problem is which people do you choose to kill? That's the trolley problem, a huge ethical problem. And the problem comes from the speed of the vehicle. So it comes from the fact that the vehicle is going too fast and detects the people at the last second. So with smartphones, we know kilometers away, like ahead, like kilometers ahead, if there's a pedestrian coming. We track people everywhere on the planet. So we can solve the trolley problem. Thank you. Next slide. This is our system, how it works. So we calculate the different stages of a braking process, and we extend 9 layers of risks around the vehicle. So like info, we also address a risk factor to the situation based on the smartphone detection and the car detection as well. So there's 9 levels. Next slide, please. And the ellipses around the vehicle change according to the speed and the direction of the vehicle and the pedestrians or any vulnerable road users. So the ellipse change, and if the ellipse of the pedestrians collide with the ellipses of the car, then we send alerts. That's the way it works, and signals to trigger the brakes. Next slides, please. So we respect SAE standards. We try not to change the industry process. We try to adapt to the reality of the industry. But to have our approach, we need to modify the standard just slightly. And we're on the SAE committees on standards right now, so we're addressing that issue. But this is for the greater good. We could save lots of lives by modifying the standards. Next slides, please. So this is an example of the log we sent to a car. It respects the DSRC CV2X standards protocol, and what we do is we provide a risk factor from 0 to 9, 9 being imminent collision brake, 0 being no risk. So there's a whole gradient of risks, and we provide also a coefficients of confidence of the log. So according to the situation of the satellites and the telecommunication infrastructures and all that, we adapt the confidence level of our risk factors. So if all the system works well, we give a high confidence level, and if there was issues at some part of the technology chain, we downgrade the confidence level of the information. Next slides, please. So that concludes our presentation. Thank you very much. I just want to add that our solution is software only. So there's no hardware to install on the car, just a software update, and no hardware or infrastructures to implement. In our cities, smartphones are already there. You can download an app, a software for free on important.com. Thank you so much.
Thank you to James, Assam, and Bastien. Thanks so much. And we are now going to take a 5-minute break. We'll resume our panel discussion in about 5 minutes. And once again, get those questions ready. We'll see you soon. Welcome back, everyone, to the Q&A section of the program. So a reminder, please submit your questions for our panel discussion in the chat box. Be sure to include which panelist you're directing the question to, or if it's just for all of them. Now, in addition to James, Assam, and Bastian, we have two experts on the topic of pedestrian safety on our panel today. First, I would like to introduce Ms. Lori Adams, Managing Principal and Director of Traffic and Safety at DGL Consulting. Lori PTP joined DGL Consulting Engineers, LLC in 1996, was elected as a principal in 1999, and was named the managing principal in 2017. Ms. Adams earned a Bachelor of Science in Civil Engineering from the University of Toledo and is a professional engineer in Ohio and in Michigan. She holds additional certification as a professional traffic operations engineer and a professional transportation planner. Lori is a recognized leader in traffic and safety across the state and has unique skills in pedestrian movement analysis within busy urban corridors, as well as school walking and biking routes. She has worked with numerous committees to obtain grant funding for safe routes to school and other safety projects. Now, Lori sits on numerous boards and committees and is active in several professional organizations, including TMACOG's Transportation Improvement Committee and the Smart Transportation and Innovative Mobility Committee. She has a long, strong stance on transportation infrastructure, its importance to the economy, and the safety of the public in all modes of public transportation. Lori is a member of the University of Toledo College of Engineering Development Committee, the Civil Engineering Industrial Advisory, and is the president of the Engineering Alumni Affiliate. Welcome, Lori Adams.
Thanks, Lisa. DGL is a civil consulting firm in Maumee, and we specialize in transportation, in parks and rec, site development, facilities, structural engineering, surveying, pretty much everything civil, construction inspection. And our work can be seen around Ohio, parts of Michigan, West Virginia, and Kentucky. We take pride in our safe routes to school work that supports safer walking and biking routes for kids. But these improvements give other safer walking and biking improvements for the community as well. And as COVID shutdowns have occurred this year, more people than ever have started walking and biking. And what we've seen is that the interfaces between trails and sidewalks with the traveling public have become even more dangerous. And instead of having less and less pedestrian injuries and fatalities, we're actually seeing more. A lot of this is due to driver distraction. It's also due to walker distraction. You saw some of Assam's slides which showing the people walking with their head down, looking at their cell phone. I'm guilty of that as well. But we need to put some responsibility on the drivers and the walkers to provide, to be aware of what's going on in their environment. It can't just be technology. Technology is very important, and I'm excited to see the advances that are being made to help drivers see and detect pedestrians and bikers. But we also need to make sure that we're doing our part as the pedestrian. So I want to be a part of the ever-changing safety solutions for all users, and I'm applauding our communities in this area, our metro parks, our cities that are looking at ways to have all modes of transportation accounted for and to be safe. Thanks.
Thank you so much. Appreciate that, Lori. Next, we have Mr. Mark Dilsaver, Project Manager for the City of Marysville, Ohio. Mark has 13 years of local government experience and has spent the last 7 years as the Project Manager for the City of Marysville. He is currently the Mobility and Construction Manager for the city. He has oversight of the traffic control system as well as construction activities within the city. Now, Mark is a member of MORPC's Sustainable 2050 Committee and serves on the Policy Committee for the North Central Ohio Solid Waste District. He is currently leading the Connected Marysville deployment, which is part of the 33 Smart Mobility Corridor project that is being funded through the Advanced Transportation and Congestion Management Technologies Deployment Federal Funding Grant Program. Welcome, Mark.
Thank you, Lisa. Yeah, so just a little bit about Marysville and what we have going on here. We're a small town of about 25,000 people, just over that. And we're northwest of Columbus, and we are located along US 33. And we're a component of the US 33 Smart Mobility Corridor, which is a 35-mile stretch of US 33 that runs between Dublin and East Liberty, Ohio. And East Liberty is where Honda has its largest manufacturing and R&D facilities in North America. Right now, currently in Marysville, we're partnering with Drive Ohio and with ODOT on two specific projects. One is the Connected Marysville project, which we are launching that this year. It's a 3-year project that will outfit 400 private citizen volunteer vehicles with onboard units that include human-machine interfaces. And that project will collect data and study driver habits along with operational logistics. The other project that we have going on here is the Drive Ohio's onboard unit integrator project, which that will install over 200 onboard units and human machine interfaces on fleet, emergency, and public service, public works vehicles. Those public works vehicles and fleet vehicles will be a combination of Marysville vehicles, our Union County vehicles, City of Dublin, Ohio vehicles, and just some of our partner vehicles, some of our partners in the corridor. Like I said, Marysville is part of has Honda right next door to us, and we're a good partner with them, and they've selected Marysville to be home of their smart intersection, and that's an intersection in our core of our uptown district, and it's outfitted with infrastructure, cameras, and computers and AI that can warn drivers of pedestrians that are outside of the crosswalk area and that may be around the corner of and out of sight of the driver, which is very important in an area like ours. We have buildings that are tall and up close to the road, and there's lots of stores, there's lots of pedestrians in the area, so not everybody stays within the crosswalk area, right? So that's been great partnership with them, and being a smaller city along the corridor, we're able to provide a real world environment where companies can test their vehicles and their technology in an environment where they won't get lost in the crowd in a larger city. So we're kind of a living lab, so to speak, but we have a lot of good stuff going on here, and I just appreciate being a part of the conversation today. Thank you.
Thank you to everyone. And now it is time to start our portion of the discussion with the Q&A portion. What can local communities do now to prepare for autonomous vehicles? And this can be for anyone.
Hello. Yeah, I'll take a risk and answer this question. What local communities? I think every city right now should think about infrastructures and their futures. It's a long process. I would not see that as a 1-year thing. I would try to approach it on a 10-year horizon and more. There's a lot of technologies available, and as mentioned, the standards are still being defined. So it doesn't mean we don't act. We have to act right now, try things. The first thing to do is to build knowledge. So maybe not start to deploy technology everywhere in the city, but start at small scale, try to do a test, learnings, and grow from that. At important, we believe we're essential part of smart city projects, because when you look at most projects, people are afraid of autonomous cars. That's they cannot. It was mentioned earlier by James. There's no eye contact with autonomous cars. So what do you do to feel safe when you cross the street and an autonomous car comes at you? Will it stop? And how do you know it stopped? And the feedback loop from the EHMI is important, like the fact that the car reacts and say sends us signals to the user, so the user recognizes it's detected. It's important, but if there's not that, at least the app can, the mobile app we're developing gives a sense for populations that they're protected and they're helping their city. So for any project, for any city, I would start at small scale and involve important right away. So the population is involved. Thank you.
Yeah, I would like to add into what Beth said. So I think from my perspective, I think first what we need to do is we need to identify where there's a lot of kind of accident within any city. Like, for example, if we are in the city of Ann Arbor, we definitely need to look into where are the most of the accidents are occurring or happening. Are they happening during the day? Are they happening during the day? And where are these accidents are happening? I think by identifying and understanding where these accidents are happening, I think we can try to help and mitigate those kind of accidents. As I mentioned, so just identifying the location, where those happen, what day, what time, and then trying to analyze why those were occur. And then from there, we're trying to implement maybe smart infrastructure where we can add maybe connected vehicles. Obviously, this could be a great challenge if we're talking about a bigger scale from city to city. Obviously, this could be very expensive. It will take longer time. But I think having a smart infrastructure could make an impact on the city itself, but also looking into some technologies that can kind of be integrated into a commercialized vehicle. Obviously, autonomous vehicle will make a big impact in the near future, but we don't know when these autonomous vehicles will be available. But I think trying to integrate kind of any technology that can prevent accident to the vehicles will make an impact. So it's kind of a combination of having smart infrastructures, smart city, and also smart vehicles as well that have that capability of communicating with one another to mitigate those kind of type of risks.
I would just like to add a comment. I think that a way to start is small, and I think like the demo projects and things like that can really help to bring along the public to gain acceptance. And I think, you know, calling up Lisa and having her do a story about your local demo project and getting it out in the news and stuff like that, and trying to really explain to people in the public, you know, what is the technology doing really, and how is it going to help improve the traffic flow, or how is it going to help improve the safety of our community. I think it's just that communication piece, I think, is really important.
That is exactly right, James, and much appreciated. So if any of you are in places that are not near here, do reach out to the media. Oftentimes, that's how we learn about these stories, and we love sharing them. So that is fantastic advice. For the AI-based techniques you have used for both info and important, are there any privacy concerns when you collect, store, and process the large amount of pedestrians' information? If so, how have you dealt with it?
Yeah, I can start. Obviously, data privacy is very important. Obviously, people do concern when maybe companies out there who's either autonomous companies or some companies like us who's collecting data on the road. We take kind of data privacy as our main top priority. The data that we're collecting on the roads are not shared with any third party. They're more used to teach and train our model in-house. Obviously, those data will be used to kind of continue teaching the model how to learn. As I mentioned, we do not share that data with third party, you know, especially when we collect data in public. As I mentioned, yes, people do concern, but I think if you use that data for good things, I think that's what matter. In our case, is we're using the data to kind of teach our model to learn and to be able to predict what's happening surrounding the vehicle. That's my takeaway is we're just using the data for good.
Yeah, and on the side of important, we care also a lot about privacy because we want to respect all the legislation present and the future legislation as well. So I showed you the code. I showed you what we send to cars. There's no private information at all. It's just a position, a direction, and a risk factor. Our system doesn't judge on age, on sex, on religion, or on anything. So we just all our data is anonymized. The only way we could know is if a coroner would like to reproduce an accident, we could manually dig the data, extract it, and find out the information for the coroners. But it had never happened yet, and we would do that with like the most serious matters. So thank you so much for this question.
Next question, and this can be for anyone. If money was not an issue, what would you want to do now and in the near future?
That's the best question ever. No money limitation. Yeah, we would develop the whole thing and make it for free. So provide the technology to save lives for free would be a nice dream, but reality makes us have to charge for that. Yeah.
Yeah, I think from our perspective, I think all of us has the same goal, is we want to focus on the safety. I think that's the main topic here we're talking about. Obviously, that's the main reason we're doing this. And that's the reason why we started, obviously Info and other companies, Component and other corporate who started this is for one reason, is we want to care about safety. Obviously, money comes later once we are able to address these type of issues. But I think we have to have a reason why we're doing this. And the thing is we're doing this for the main reason is for not for just for us, for a generation to come. Is I think they will thank us for what we're doing today. And I think that's where I see the main impact is to create something that making an impact on us and generation to come in the future.
Just a really quick comment. I think that I would use the money to ensure good accessibility of technology. So make sure that as we roll things out, it's rolled out like to everybody. Like everybody's using the transportation system, and everybody should have that kind of access to all the best technology. So that's how I would use it.
It is truly amazing how quickly the technology is changing and improving. But how do you really make people comfortable? There really are an awful lot of people who just, it's going to be a long process.
I think from my perspective, I would say I think education is very important. I think, talking about, I guess, universities, I think there has to be a lot of kind of introductions to courses into autonomous vehicle that kind of let people know what are these autonomous, how they work, what they're trying to do in the future. Obviously, technology is moving quickly. You sleep, you wake up in the morning, something new comes up. So I think obviously at school, in social media, we need to provide as much information to the public to let them know what we're doing differently and how we are making an impact. Obviously, of course, today vehicles on the road are not that safe. Obviously, we all agree that even autonomous vehicles, they're not as extremely as safe as people think. But we're actually going into that milestone that we're trying to target, which is to make these vehicles safe. I think that's something that we want people to know. And obviously, we want people to know that do not trust autonomous vehicles today because they're not have that type of capability to take control of everything. So we have to be careful. And I think education is the key here.
This is for everyone. What do you think will be the next big hardware, software technology that will advance autonomous driving into the mainstream? So that sort of fits right into that prior question. For example, LiDAR, standardized radio communications, camera, 5G, etc. Once again, that's for everyone.
Yeah, I can try to answer this. I don't believe in a magical technology. So most of the problem comes from that sensors don't see through vehicles, and I don't see that happening. Sensor that see through vehicles or trucks or buildings or it might be a long process. So I think all the technology is available today. We are in an exciting time right now. We're setting the industry for the future generation, as Hassan mentioned. And this year will be a key year. And 2021, a lot of the decisions will be taken. There's a lot of projects coming on in America and around the world about smart cities. And yeah, I think all the technology is already there. It's a matter of agreeing on the ones that we want to propose to population and develop that. But we'll have to make choices this year.
I think one of the technologies you mentioned was 5G, and I think that is going to be important. I think that the cellular phone industry is a powerful industry, and I think that we've, in the development of cell phones, in the early days of cell phones, there was a lot of safety concerns about drivers having cell phones and being able to use cell phones while they're driving, and yet we have them, and I think that the switch over from or the impetus now to move connected vehicle technology to the cellular network, I think it's going to happen, and I think there may be some advantages in that, and I think that is actually going to be a technology that is going to change the development of or change the implementation of autonomous and connected vehicles.
And related to GPS location, if cell towers or satellite signals stop, hopefully temporarily, will these vehicles be able to find a safe, convenient off-road place to park until that interruption is rectified?
Yeah, so what do we do when the system stops to work, right? That's a question for cars. So that's where the tech stack is so important. You cannot rely on only one technology. Every technology has its limitation. It's the stack of different technologies that makes it reliable, makes the whole system reliable.
And I would say, I think the next probably 5 to 10 years, even if we have a good kind of robust, let's say level 3 or level 5 autonomy vehicle, even if there's any disconnection in terms of software or if there's no GPS within the location, I think drivers should have the capability of taking control of the vehicle. This should always remain as part of the stack of the autonomous vehicle. Because in the event when there's something happen, obviously we want the driver to take control of that. And I think that will remain. We will eventually see that in the future that drivers will always can control the vehicles at some point. Maybe in the next 30 to 50 years, then we will have a fully autonomous vehicle. There's no human involved in that case. But I think in order to adopt these technologies, and especially people to educate on this technology and how the technology works, is we want them to be able to take control of the vehicle. Again, because these technologies that are coming are really brand new. Probably they do have a lot of limitation, and we want to make sure these are extremely safe. Obviously, good are involving, and obviously, we're seeing good kind of companies are bringing these technologies to the market, but again, how robust are these technologies? That's the question.
Another question for anyone. What do you envision as the trajectory for autonomous vehicles, this technology for use in public safety vehicles like police and fire? Does the industry envision a leading or lagging adaptation in this area for public safety? And if so, why?
That's a really tough question for me. I'm not an expert in public safety vehicles, but I would say, you know, we do have like traffic signal preemption for emergency vehicles, and so I think that there is that foundation is already there for use of technology to support more efficient operations for those kind of vehicles. So I think that I just don't have I don't have a good feeling on the level of acceptance and within that sort of sector for it. But I think it could happen soon, but I really don't know.
Yeah, maybe I can complement right now. I think before autonomy for these vehicles, connectivity will start. So it will start with connectivity already. These vehicles needs to be connected for emergency, situations and sending alerts to people. So already with our mobile app, we communicate with systems, emergency systems to alert either drivers or alert users. But it's more the connectivity that will start. But when it comes to autonomy, it might take a long time before we see that.
Yeah, and just to kind of back up what Bastian was saying, here in Marysville, I mentioned the Honda Smart intersection. One of the applications that they've demoed is an emergency vehicle warning where the connected vehicle, it's vehicle to infrastructure technology. So the infrastructure detects an emergency vehicle approaching the intersection and warns a driver on an adjacent road of the approaching emergency vehicle. Again, Marysville has lots of taller buildings and tight turns, and so that's been a huge thing and really neat to see, really. So again, I agree with Bastian. It's a step process of starting out with connected vehicles, talking to the infrastructure that can see things that the vehicle maybe can't, and then eventually maybe progressing to the autonomous world.
Thank you so much. Another question for everyone. Is there a plan to look at road service events, so a broken down vehicle, for example, to help with protecting emergency roadside providers like AAA, who may be changing a tire on the road, for example, or a police officer who is speaking with a driver during a traffic stop?
So I can jump in on the work zone or the broken down vehicle, side of that. One of the applications that we're working on with our smart mobility corridor is here in Marysville in the US 33 corridor is a work zone or lane closed ahead, application or warning to the drivers' vehicles that are on the highway. And so whether it's a work zone that may be mobile or stationary, or with the hopes of eventually maybe it is a communication aspect with a cruiser, a law enforcement officer on the side of the road where that cruiser can talk to the roadside unit and then relay that information back to either the roadside unit or to connected vehicles or vehicle to vehicle, but we are working on the vehicle to infrastructure technology for that aspect now.
And I think from the autonomous perspective, if we're talking about ADAS and fully autonomous, I think GPS are doing a great job today of kind of identifying when there's like for example, road assistance needed to be done, or maybe police or an accident that can occur on the road. But obviously, I do believe that in the future, the cameras will be able to kind of flag those accidents and be able to identify what happened on the road for each vehicle, and could send that signal back to maybe either to the smart infrastructure, where they can kind of share that data with other users within the same vehicle. So I think it could be a combination of having sensors within the vehicle that can send those signals to the connected or to the smart city, where they can also pass that data to other road users.
Thank you so much to everyone. There were some excellent questions. Apologize, we weren't able to get to them all, but there were really, a lot of insightful answers to all of those questions as well. It's been very interesting. And before we wrap up with today's seminar, it is my pleasure to introduce to everyone AAA Senior Executive Vice President, Edgar Avila.
Good afternoon, everyone, and thank you for joining us today. On behalf of AAA Northwest Ohio and the University of Toledo College of Engineering, we want to thank Lisa Guyton for serving as MC and moderator, and of course to the speakers and panelists for their presentations and the Q&A that followed. Also on behalf of AAA, I would like to thank our wonderful partners at the University of Toledo College of Engineering for their continued support hosting Technology Takes the Wheel speaker series over the past 3 years. Now, today will be the last speaker series where I will be delivering closing remarks on behalf of AAA, as I will be retiring on May 1st. While I may be retiring, I still plan to attend future events that someday will again be held at the university's Nitschke Auditorium. As I look back over the past 3 years, the creation of Technology Takes the Wheel is one of the initiatives I am most proud of during my 8 years with AAA. The initial motivation to create Technology Takes the Wheel was driven in large part by the October 2017 launch of a self-driving shuttle bus in downtown Las Vegas and a AAA-sponsored TEDx talk on the topic of transformation of transportation held that very same month. 5 months later, in March of 2018, we had a reality check when an Uber self-driving vehicle was involved in the first pedestrian fatality in Tempe, Arizona. This tragic development reinforced the need to educate the public on automated and connected vehicle technology and how it may impact drivers, pedestrians, and bicyclists. AAA will do its part by continuing to expand the speaker series, which now has over a dozen universities hosting these events, to educate the public on smart mobility technology. AAA will continue to advocate at the state and federal level for traffic safety regulations and testing of smart mobility and transportation technology. What we now know for certain is that change is coming. With the public's greater acceptance of electric vehicles and the future promise of self-driving vehicles, major vehicle manufacturers are now racing to develop electric vehicles and to eventually offer self-driving options. Last month, GM publicly stated they plan to only manufacture electric vehicles by 2035, with a goal for GM to be carbon neutral by 2040. Just this past December, GM's Cruise subsidiary began testing self-driving vehicles in San Francisco. And several other vehicle manufacturers have announced plans to phase out gasoline-powered vehicles and to focus solely on electric vehicles. So change is coming, and the changes are coming faster than we all initially anticipated. As we continue on the smart mobility innovation journey, I want to wish AAA and the University of Toledo continued success with Technology Takes the Wheel. It has been my honor and privilege to have worked with many outstanding transportation leaders, engineers, and scientists over the past 3 years. I am proud that we were able to bring in expert speakers and panelists to enlighten us on the transformation of transportation and the opportunities and implications of smart mobility technology on society, businesses, and government. Thank you very much for listening, and Lisa, back to you.
Thank you so much for all you have done on a number of levels for this community through the years, Edgar. We're going to miss you.
Thank you.
I want to give a heartfelt thank you also to our speakers and panelists and to all of you in the audience today. Thank you to the co-sponsors of this series, the University of Toledo College of Engineering and AAA of Northwest Ohio. Watch for notification of our next seminar coming up in the near future. And if you registered for CPD certificates, those will be emailed to you at the email address you provided. Thank you so much, everyone, for being here today. Have a wonderful weekend, and we will see you soon.